Hi guys, sorry we didn't have another video since the review of the test, but this is what we're going to be doing for the next section. I think you'll find this pretty easy, but it's important that you practice a lot with this. These are called inverse functions. The notation for inverse functions are either this little -1, which isn't a negative exponent. It's just the notation for an inverse function. Sometimes it's called inverse sine, or it could be called the arc sine as well. I think we might have talked about that a little bit in class, but I'll go over it with you. And really what this is asking is they're saying, for what angle is the sine equal to square root of 3 over 2? So it's asking a question. And very simply, if you just look at your unit circle, and you look at where does square root of 3 over 2 come in, that would be at pi over 6. So, I'm sorry, it would be at pi over 3. So the sine is always the y-coordinate, right? Where in the unit circle where the radius is 1. And what would happen is we would get the square root of 3 over 2 over 1, which is opposite over hypotenuse. So this one, the square root of 3 over 2, would then be just a pi over 3. So this one would equal a pi over 3. For question number 6 on page 626, they're asking, for what angle is the sine equal to a negative square root of 3 over 2? And if you go back to your unit circle, the negative square root of 3 over 2 comes down here, and the angle where the y-coordinate is negative square root of 3 over 2 is 5 pi over 3. So this one would be a 5 pi over 3. So this inverse function is always equal to an angle. And that's what that's the question that it always asks. Like for example, number 8, it says, for what angle is the cosine equal to square root of 2 over 2? And if you look here, square root of 2 over 2, x-coordinate, because we're talking about cosine, that would be 45 degrees, or equal to pi over 4. Some of them are a little bit more complicated, and you have to think a little bit more. It's usually the tangent ones. But where is the tangent equal to 1? I have to think about when I divide y by x, what angle is going to give me a 1? And again, that would be pi over 4, or 45 degrees. Because this and this are the same. So this would be 45 degrees or pi over 4. For number 18 on this page 626, they're asking, for what angle is the tangent equal to square root of 3 over 3? Well, I don't have that on here. So I have to think about, when I divide the y by the x, when does it come out to be square root of 3 over 3? Negative though. So square root of 3 over, so think about, say this one. We'll look in this first quadrant, but it's going to be down here because it's negative. When I divide y by x, I get square root of 3 over 2 over 1/2. Square root of 3 over 2 over 1/2. Flip the bottom over and multiply up top, and we'll get this, and we get square root of 3. Well, so that's not it. So maybe it would be the other one. This 1/2 over 3 square root of 2. So 1/2 over square root of 3 over 2. If I multiply this up top, I'll get 1/2 times 2 square root of 3. The 2's cancel out. I get this. If I rationalize this number by multiplying the top and the bottom by the square root of 3, we can get square root of 3 over 3. See that, square root of 3 over square root of 9, which is just 3. So this one came out to be that angle where the y-coordinate was 1/2, and the x-coordinate is this, but it's negative. I need it down here. So this would be 11 pi over 6. So our answer would be 11 pi over 6, because that's where that angle occurs, where the y is 1/2, and the x is square root of 3 over 2, producing this as an answer. So this one would be the negative, so that would come out to be negative. So you can look at these again. The next type of problem that they're asking us about we're going to jump over to number 32. Just realize that the cosine and the inverse cosine are opposites. In a sense, they kind of cancel each other out. So this one here, understanding that this is an angle, and even though I don't know what it is, this angle, the cosine of this angle, it's going to come out to be just 0.57. Because these are opposites, and you'll see a bunch of problems like that, again from page 626. The next one is they're saying, what is the sine of this angle? And realizing that this is an angle. It's an angle whose opposite side is 7 and whose adjacent side is 24. So I drew a triangle here to show the opposite side being 7 and the adjacent side being 24. But to use a sine, I need a hypotenuse. So I used the Pythagorean theorem to find out what this is. This would be 49 and 476. Add them together, take the square root of both sides. You get 25. If this side then comes out to be 25, the sine of this angle, even though I don't know what it is going to be the opposite over the hypotenuse, which is 7 over 25. Take a good look at that. Pause it and think about it for a while. Retry the problem, and then you're going to try some of the odd ones on your own. The next type of problem is sometimes they use a secant or a cosecant. Same thing, this is an angle. This asks us for what angle is the sine equal to -1/2. Well, let's take a look. For what angle is the sine, oops, I got this upside down, it's equal to -1/2. That would be over here. This would be 11 pi over 6, where the y coordinate is a -1/2. So this would be our angle right here. This thing came out to be 11 pi over 6. If we take this and find out what the secant is, well, the secant is the reciprocal of the cosine. The cosine of 11 pi over 6, if again we look at our unit circle, is going to be square root of 3 over 2, cosine being the x coordinate. So this is going to be square root of 3 over 2, but the secant is the reciprocal of that, so I flipped this over, and that's how I got this. Rationalize the denominator by multiplying the top and the bottom by the square root of 3, and then we get this for an answer. This would be our final answer. These are the type of problems that you should be working on in the next few days. And let me tell you exactly which ones that you need to do for homework. So again, this is page 626 and 627. I want you to be able to do all of these that you see from 1 to 62. Do the odd ones, and then check all your answers in the back of the book. If you can't solve one, if you absolutely can't solve one, then send me an email, and I'll try to get back to you as quickly as I can. So the other problems that you should try is some of these word problems that are on page 638, and I want you to try 41 to 48. And you could start out with the odd ones, but then also go and do the even ones. Your test next week, whether it be on a Monday or Wednesday, I'm not 100% sure yet, will depend on the emails that come in, will be a couple of problems from here and a couple of problems from here. So good luck, and I'll talk to you soon. Bye-bye.